Alright, in this video we're going to be looking at how to differentiate functions using the chain rule. The chain rule is applied for when formulas of functions look like the following. So if we have some function y is equal to a bracket with some function inside it to the power of an integer. If we have a function that looks like this, to work out the derivative dy on dx, all we simply do is we bring the power to the front, we times by the derivative of the inside function, so in this case f of x, the derivative of that would just be f dash x, and then we keep the function again, and then we just minus away 1 from the power. And this is how you would use the chain rule to differentiate any sort of a function. So let's go through a few examples to consolidate our understanding. The first question we're going to try and differentiate is this one here. So to differentiate this function, we would need to use the chain rule. And the key giveaway that tells us to use the chain rule is we have some bracket to the power of an integer. And inside of that bracket, we don't only have a constant, we have a function in terms of x. So all I'm going to do to differentiate this is I'm going to bring the 4 to the front. Then I'm going to times by the derivative of my inside function. And the derivative of x squared is simply 2x. And then I'm going to times by the function that I have minus away 1 from the power. So in this case, it's x squared plus 1 to the power of 3. Simplifying this, we'll get 8x x squared plus 1 to the power of 3. And that is the derivative for this function here. Let's keep going. The next question we're going to be doing is 1 take x squared to the power of minus 3. Again, it's the same rule. We would use the chain rule. So to differentiate this, all we would do is we would bring the power to the front, so minus 3. And then we would differentiate the inside function, which in this case is minus 2x. And then we keep the function as is, but all we do is we minus 1 from the power. And minusing 1 from the power will give us minus 4. And if we wanted to simplify this, we can times these two brackets together. So minus 3 times by minus 2x is simply equal to just 6x. And we can also make our index in this function a positive index by simply bringing it to the denominator. So we can simplify this by saying it is 6x divided by 1 take x squared to the power of 4. And that is the derivative of this function here. The next question we're going to be doing is y equals to 6 plus 6x plus 1 to the power of 5. To differentiate this, we would bring the power to the front, differentiate the inside function, so 6, and then we would keep the function as is, but just minus 1 from the power. And now we have 30 times 6x plus 1 to the power of 4. That is the derivative of this function here. Next question we're going to be doing is y equals x cubed plus 2x squared plus x to the power of 4. To differentiate, it looks a little bit more complicated because it's a cubic. It is still the exact same rule. To differentiate this, we would use the chain rule by bringing first the power to the front, differentiate the inside function, and then we would times by the original function, and then minus away 1 from the power. And in this question here, we can simplify and expand and differentiate. Expand and simplify, but I'm not going to do that for this problem here. This is the derivative of the above function. Next question we're going to do is we're going to be working out the derivative for y equals 6x cubed plus 2 over x to the power of a half. To differentiate this, we would bring the power to the front. So we'd bring the half to the front. Then we would times by the derivative of the inside function. The derivative of 6x cubed is simply bring the 3 to the front. We would have 3 times 6x to the power of 2, and that would be 18x squared. And to find the derivative of 2 on x, I'm just going to write it as 2x to the power of minus 1. So then when we try to differentiate it, you bring the minus 1 to the front, so minus 1 times 2x to the power of minus 1 minus 1. And that would simply simplify to minus 2x to the power of minus 2, or simply minus 2x, simply minus 2 over x squared. So we can do that to this one as well. And then we can keep the original function to the power of half minus 1, which in this case would simply be minus a half. The only thing I'm going to do to simplify this is I'm just going to rationalize, I'm going to make this index positive, and I'm just going to keep everything on the top, and then bring this function towards the denominator, and we can make it square rooted, and say it's 6x cubed plus 2 over x. And if we wanted to, we can times this half into both of these terms here. So I'm simply just going to say it would be 9 for this term here, because half of 18 is 9, and then half of 2 is simply 1. That is the derivative of this function here. The next one we're going to be doing is y equals to cos x plus x to the power of 7. To find the derivative, we bring the power to the front, times by the derivative of the inside function. The derivative of cos x is minus sine x, and the derivative of x is plus 1. And then we times by the function again, and then we raise it to 1 minus whatever it is at the top. The next one we're going to be doing is y equals to x squared plus 2x take away e to the power of x to the power of a half. And another way they could give this question is they could simply just give it to you as the square root. And to differentiate this, we would then have to formulate this as to the power of a half. So I would just simply write it as x squared plus 2x take e to the x, all raised to the power of a half. Now to simplify, we can write this as bring the power to the front, times it by the derivative of the inside function. So the derivative of x squared is 2x, derivative of 2x is plus 2, and the derivative of e to the power of x is simply minus e to the power of x. And then we can times by the original function, just raised to the power of a half minus 1, which in this case would simply be minus a half. And we could simplify this if you wanted by just making this a negative power. I keep saying rationalizing for some reason today. And then 2x plus 2 take e to the x all over the square root of x squared plus 2x take e to the x. And it's always common practice to not have a fraction inside of a fraction. So another way of saying timesing this entire fraction by a half is simply by timesing this numerator by 1 and the denominator by 2. So instead of saying a half on the top, we can simply just write 1 here and 2 here, and we don't really need the 1 at the top, or the brackets. That is the chain rule for you in this question here.